Okay, now we will see, we're continuing here the Rambam Kiddush HaChodesh, Perik Yud Zayin, Halacha Yud Beis. Zog the Rambam. Ve'achar kach, Tag ze v'tir ha'oich ha'shlishi hazeh, v'hu ha'mayle shebein ha'yereich v'hashemesh, be'eze mazel hu. So now the Rambam explains what orec reviiA means, and I must say orec reviiA is quite simple because it's not as complicated as orec sheni to orec shlishi. Orec shlishi to orec reviiA is simply taking the minutes, or you can say degrees, it takes for the certain portions of the ecliptic to set, the Galgal Mazals. So we have now orec shlishi, but that is the 2 points on the ecliptic. One point is where the sun is. The other point is a little bit complicated. It's a point that shares the same right ascension that where the moon is. It's also a point on the ecliptic. However, it's a very theoretical point because it's not a point where the moon is. It's just we're using this as a reference point because this is a nice approximation to see how long it will take from sunset to moonset. So again, we're having here 2 points on the ecliptic. The first point is where the sun is right now, that we know from a long time ago, Makam Shemesh Amiti. The second point is a calculated point from a complicated formula that we said a previous shiurim that gives us which point on the ecliptic has the right ascension of the moon, where the moon is now. So we have now another point. Now these 2 points are both on the ecliptic. So here comes the $1 million question. How long does it take for points on the ecliptic to set? For 2 given points. So let's see what the Rambam says. Im ye b'mazel dogim. The Rambam is going to tell us here we're going to see soon the actual we're going to see soon the charts, but let's first see the basic Rambam inside. He says like this: Im ye b'mazel dogim b'mazel tle. If the orec shlishi is in dogim or in tle, toisav al orec shlishi shetusa. You have to add a sixth. So let me give you numbers right away because it shouldn't be theoretical. You should right away what's happening here. So let's make the sun is im yeh b'mazel dogim or b'mazel tle. It means where the im yeh, you're talking about the moon. So the sun also, because we will assume that the Rambam talks about the moon here. Let's see let's make an example. The sun is on 0 tle. The moon is 15 degrees. Not the moon. The orec shlishi is there. The moon could be somewhere else. But this point on the ecliptic is chosen for the moon because it has the same right ascension where the moon really is. So we choose now, we have 2 points. We have point 0 and 15 on the ecliptic. Or tle would mean we'll make the the sun, you have to understand, after the beginning of the Chodesh, the sun is always, the moon is always a little bit is higher degrees than the sun. So if the moon is 15, the sun can be 0. If the moon is 0, the sun would be 345. So this could be two examples where they're both in the area of Dagim al Taleh. So what do? So we have here 15 degrees on the ecliptic. The difference on the ecliptic is 15 degrees. However, the Rambam says, please do me a favor, add a sixth. So a sixth of 15 is, we take a calculator, we make 16 divided by 5. And it's 3.2. So you must add 3.2 degrees. So instead of saying 15, you take a paper, you write down orec shlishi is 15, orec reviiA is 15 plus 3.2, that is 18.2. Orec reviiA is now 18.2. Next, reviiA orec b'mazel deli or b'mazel shoyer. The Rambam goes both directions, both have the same. Doesn't matter. It's like a symmetrical point where Taleh is the center, and you can go right or left. We'll show soon diagrams for this, but you can go either negative or positive, and they have the same amount of adding to the or subtracting to the orec shlishi. So now, im yeh orec b'mazel deli or b'mazel shoyer. So let's make an example again. Let's use the positive way. So we'll say the sun would be on the sun would be 30, the moon would be 45. I try to make 15 degrees, easy number, and that's how much in the beginning of the month, it's about 15 degrees like apart. So the sun is 30 on the ecliptic, the end of, that's the beginning of Shoyer, and the moon is 45 degrees. And the same thing you can say the other way, you can go in the negative side, so you make 360 minus 30 is 330, and then you make 360 minus 45, that will be 315. So here again you can say the sun is 315, the moon is 330. Remember, the moon is always higher number than the sun. So next, what do you do then? Then you add even more. So in this case, we say, instead of writing down that we wrote down first orec shlishi is 15. However, we take a fifth of that. That's a fifth of 15 is 3 degrees. That's a lot. So instead of 15, you write down on the paper 18. The orec reviiA is 18. Since you're dealing in this area of the ecliptic, that is from 30 to 45, or 30 to 60 rather, it can be also 35 to 50, any area that's in the mazel of Shoyer. Next, mazel gedi or mazel te'umim, toisav ala orec shlishi shetuse, then goes back again to lower. Orec mazel gedi would be already from 60. Yeah, because Shoyer is 30, that's 360. Te'umim is the other way, it's 360 minus 60. Then you only go, it's a lesser addition. If it's in the area that's 90 degrees on the ecliptic, so let's say the sun would be 90 and the moon would be 105, then don't touch it. Just leave it on 15. The same goes minus 90, so it's from 270. Let's say you have 270, and 255. That's 15 degrees apart. Next. Then again, Tigra. Then you go minus. Here it's the other way around. Here we take this number, so we have here 90 plus 30, that's 120. So let's say we have, for instance, we have the two numbers is 120 and 135. That's the moon is 135, the sun is 120. So what we do is, instead of writing 15, we subtract a fifth. So a fifth of 15 is 3, so we end up with 12. That's our orec reviiA. ואם יהיה האורך במזל מאזניים או במזל בסולה, תיגרע מן האורך השלישי שלישיסוי. It's a huge deduction, huge. You never add a third, but you subtract a third. So that's what we do. We'll see the charts, like all these things. First, I want to just say what the Rambam says without understanding, just reading and seeing what you do. So if it's the Mazel is 9, that's 180. Mazel Basula is the other way. That's that these bows are close to 180. So we would say from 180 to till 210, or from 150 to 180. This whole area, there it's the worst. You have to deduct a third. So let's give an example. Let's say we have 180 and 2 and make 15 degrees. So 180 would be 195. We have the moon at 195. So we would say, oh, it's 15 degrees apart. That's the orec shlishi. However, the orec reviiA tells you take this 15 and deduct a third, so it's 10 degrees only. From 15 to jump down to 10. So the Rambam gives us a very simple way. It just takes, it's either a sixth, a fifth, or nothing, or deducting a fifth or a third. That's all the options he gives us here. Again, let's go review what he gives us options here. Either you add a sixth, you add a fifth. Again, he gives you another case where you just add a sixth, then do nothing. That's the fourth option. Then you deduct a fifth, or you deduct a third. So there are 6 options. Each option is done for either direction. So it's like there is a, you can make like a circle and draw the 12 mazalas and see how, you can make a circle and see how each option shares 2 different spots, because it's in either direction that that thing takes place. That's the Yisoid of this Rambam. Okay, now I would like just to start to show you a little bit what's going on here mathematically. We'll start with this diagram. This teaches you how the celestial equator is always a certain degree towards the horizon. You see there's an horizon here. There's the latitude, celestial North Pole. This is the zenith. This is in Eretz Yisrael. This is 32 degrees above this horizon. The celestial equator is 58 degrees. It's always 58 degrees towards the southern horizon. This is called celestial equator. So this turns. So this equator is an imaginary line that keeps on turning throughout the day and the night. and it's always uniform. Each degree of the celestial equator takes 4 minutes. 4 minutes to set. It sets here. This is north, south. Oh, actually, north, south. Yeah, here's west. So every 4 minutes, another degree sets. Okay. Now, there's also we have an ecliptic that's with not you don't show on see it on this picture. That's 3.5 degrees inclined towards the celestial equator. So during a 24-hour period, as celestial equator turns, it's constantly 58 inclination towards. The ecliptic keeps on changing its declination. Very important. Very important. The best way to see this is to have an actual globe, celestial globe, and to see how you set it up for your location. Then you see when you turn it that the inclination of the ecliptic keeps on changing towards the horizon because the ecliptic is not on the celestial equator. It's tilted. So it depends, and you know what, let me not explain it because it's not going to help. Just do it yourself. Get yourself. Soon I'll show another picture, maybe you'll understand better. So anyway, because of this, this is the most important upshot from this whole speech. The celestial equator sets uniformly. Every degree takes 4 minutes. However, the ecliptic is not like that. It depends. So let's say you have the celestial equator, and you have 10 degrees of the celestial equator setting. It takes 40 minutes. You can ask a question, how many degrees of the ecliptic have set in these 40 minutes? Answer is, depends which degrees of the ecliptic you're talking about. That's going to be the whole topic. Depends where on the ecliptic are you talking. It could be that in these 10 degrees, 13 degrees of the ecliptic have set, or only 8 degrees of the ecliptic have set. Depends which part of the ecliptic is touching the horizon, and you want to ask them the following 10 degrees of the celestial equator, or rather the following 40 minutes. How many degrees of ecliptic will set in the following 40 minutes? The answer is, what is right now on the horizon, and what are you expecting? Which piece of the ecliptic are you expecting to set? That is the aside of this whole thing. Okay, here you see a little bit this picture, because here you see in this diagram, you see everything. You see here the celestial equator, you see here the horizon, you see the ecliptic. So you can see all these three things together, and you see that it's not so simple what's happening here. Again, you cannot see the whole thing only if you do it yourself, but at least now I'm writing here, to really understand what's happening, get a small globe you can get in a 99-cent store. Then imagine that this is a celestial sphere, not a world globe, just a regular. And take a glass that exactly half of this globe fits in. Make sure the equator, now the celestial equator, is 58 degrees inclined towards the rim of the glass. The rim of the glass is the horizon. Also mark on the globe with the magic marker the elliptic circle. It should touch the celestial equator at 2 points. That you can use 0 and 80 of the longitude as the 2 points. Half of the ecliptic is below celestial equator and half is above. Now start running the globe, but make sure celestial equator is always 58 degrees towards the horizon. You'll realize that the ecliptic keeps on changing its inclination towards the horizon. Let's draw a sketch for the spherical triangle we need to solve in order to know how long it will take for the flare to set. So this is a spherical picture. Okay, I think we'll continue this next year already. Okay, thank you for listening.